Hi everyone, my name is Krishnaveni. I am working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management in Chemistry Department. Today I am here to discuss some important topics from Module 3, which is nothing but the polymeric materials. In polymeric materials, we will have to discuss about the addition polymerization. Polymerization means we know the monomers will combine and form a large molecule of polymer. In addition polymerization to happen, we should have the monomer which will have the double bond. A carbon-carbon double bond is needed in the monomer. A monomer is a small molecule that makes up the polymer we know. Number of monomers will combine together and they will form the polymer. In addition polymerization reaction, to form a polymer, the monomers must have the double bond. This is one of the important point which you have to note in the addition polymerization reactions. Behalf of that, in addition polymerization reactions, no byproducts will be formed along with the product. Here see the ethene molecule C2H4 which is having the double bond. When it reacts in the presence of high pressure, in the presence of traces of O2, in the presence of catalyst, it will form the polythene. Okay, number of N molecules of the ethene will react in these experimental conditions in presence of high pressure, in presence of traces of O2 will act as catalyst. The polythene will be formed. Here the double bonds will be disappeared and we will get the single bonded polymer, nothing but the polythene. Okay, here we did not get any byproduct. In addition polymerization reactions, we didn't get any byproduct. In addition polymerization reaction, it will be occurred in 3 steps. First step is the initiation, second step is the propagation, third step is the termination reaction. Okay, first the initiation step. The name indicates it is the initiation step in which it will initiate the reaction. Okay, how it will initiate? The initiation reactions will take place with the help of a free radical. Okay, the free radical will be generated from the peroxides. Okay, the free radical means the atom which will have the only one single unit, single electron. Single electron is called the free radical. Okay, this free radical will initiate the reaction. It will react with our ethene molecule which will having the double bond and it will generate the ethene free radical. Ethene free radical. This is the first important step. Next step is the propagation step. In propagation step, the free radicals, the ethene free radicals which are formed in the initiation step, they will undergo the propagation. Means the length of the polymer chain will go on increase in this propagation step. That means the chain will propagate. The chain will propagate with the combination of the two ethene free radicals. Okay, this free radical will go on react with another ethene molecule and it will be converted into free radical and these two combine and the chain will propagate with the free radical. Okay, this is the propagation step. In this step the chain will propagate. When we want to terminate the reaction, stop the reaction, we have to terminate the reaction. The termination is this step is called the third step, final step, and this the termination step is carried out by two processes. One is the disproportion reaction and another one is the combination. In disproportion reaction, the polymerization reaction, the propagation will be stopped by the formation of the double bond in one of the polymer chain by the removal of the hydrogens from the two polymer chains, and in the combination step, the two polymer free radical molecules will combine and form a large polymer molecule. This is called the combination. Means here in disproportionation reaction, the double bonded will form in one of the polymer chain with the removal of the hydrogens from the two free radical polymers. Whereas coming to in combination step, the two just free radicals will combine together and the reaction will be stopped. Okay, these are the 3 main steps which are involved in the addition polymerization reaction: initiation, propagation and termination. Here we can see no byproduct is formed in this addition polymerization reaction. Next one is condensation polymerization. Okay, what are condensation polymers? Condensation polymers are formed from condensation reaction between monomers. A small molecule is produced as well as the polymer. Okay, many natural polymers are condensation polymers. Examples: silk, starch and DNA. Okay, in condensation polymerization reaction, byproducts are formed along with our products. This is the main difference between addition polymerization and condensation polymerization. The byproduct is naturally the water. The water will be one of the byproduct in the condensation polymerization. The two main types of condensation polymers are polyester and polyamides. We can see some of the synthesis of the polymers through condensation polymerization reaction. Here see, this is one of the monomer. Just we can see with this figure. These two combine through condensation polymerization. The byproduct water is released. Okay, here our polymer is obtained, bond between the repeating units. Okay, this is our desired condensed polymer. One of the example of the condensation polymerization: formation of nylon 6,6. Okay, nylon 6,6 is a polymer formed by the condensation of the hexamethylene diamine with adipic acid. Hexamethylene diamine. Here 6 molecules of ethylene and 2 molecules of diamine. This is the hexamethylene diamine. It will react with the tetramethylene dicarboxylic acid. 4 molecules of methylene, 2 molecules of carboxylic acid. Tetramethylene dicarboxylic acid. It is also called as the adipic acid. Okay, these two form, and along with the release of the water molecule, we will get the nylon 6,6. See here, from NH2 the H hydrogen, and from adipic acid OH. Okay, these two combine and react, and the byproduct water will be released. Okay, the hydrogen from the amine molecule and the OH from the adipic acid will both combine, and the water will be released as the byproduct. Okay, this is how the nylon 6,6 will be formed from the condensation polymerization reaction. Okay, another example is the formation of pteryline. Pteryline polymer is formed by the condensation of ethylene glycol with terephthalic acid. Okay, ethylene glycol, CH2OH, CH2OH. This is the ethylene glycol. OH is the alcohol group. Okay, ethylene glycol. N molecules of ethylene glycol will react with the terephthalic acid, tetramethylene dicarboxylic acid. It undergoes the condensation polymerization reaction, and here our pteryline will be formed. This is the ester bond. C double bond O is called as the ester bond. In this pteryline we will get the ester bond formation. Okay, these are the two examples of the condensation polymerization reaction. Next, coming to the plastics or resins. And what are plastics? In our daily life we use so many plastic materials like water bottles and lunch boxes. Okay, and so many things in our daily life we use the plastic materials and organic substances with high molecular weight, which can be molded into any desired form when subjected to heat or pressure in the presence of catalyst, is called plastic. A plastic is an organic substance which can be molded to any desired shape when they undergone the reaction at high temperatures and pressure. It is called as a catalyst. Plastic. Okay, the term plastic must be differentiated from the resins. Resins are basic binding materials which form a major part of the plastic, which actually undergo polymerization reaction and condensation reaction during this preparation. However, the term resin and plastic are considered as synonyms. Means the resins are the basic part of the plastics. After the resins have undergone so many reactions in the presence of the pressure and temperature, in the presence of catalyst, they will be converted into plastics. Okay, synonyms means they have the same meaning. Okay, these are the synonyms. Now coming to the different types of plastics, we have thermoplastics and thermosettings. What are thermoplastics? Thermoplastics are the plastics which can be molded easily, and thermosettings are the plastics they cannot be molded. Okay, when thermoplastics are heated, they will get soft, and when they are cool, they become hard, and we can mold the thermoplastics into a desirable shape. But when thermosetting plastics, when they are heated continuously, they are discarded. They cannot be remolded into another desired shape. Okay, this is the main difference. Why this difference between thermoplastics and thermosettings? In thermoplastics, no links between the polymer chains helps to move. See here, this is the linear chain in the thermoplastics. We can observe. In thermosettings, links between the polymer chain stops movement between them. See here, this is the linear chain, and we have the links between these polymers also. That's why the thermosettings are very hard in nature and they cannot be remolded when we heat it. Okay, thermoplastics did not have any links between the polymer chains. Okay, that's why they can be remolded. Okay, next, polyvinyl chloride, PVC. Okay, it is obtained by heating of water emulsion of vinyl chloride in the presence of peroxide. Okay, polyvinyl chloride, PVC. We can see the PVC switchboards, PVC pipelines. Okay, so many day-to-day applications of the PVCs. Okay, this is one of the important polymer. Coming to the properties of the PVC, it is colorless, odorless, non-inflammable, and chemically inert. Okay, and its pure resins have a softening point of 148 degrees centigrade. Okay, the PVC in the form of resin, it will have the softening point of 148 degrees centigrade. Means at 148 degrees centigrade it becomes soft, and we can remold that PVC material into our desired shapes. Whichever product we want, we can mold it into our desired shapes. Okay, uses: rigid PVC or unplasticized PVC used for making sheets, light fitting, helmets, tire refrigerators, mudguards. Okay, this PVC is again divided into unplasticized PVC and plasticized PVC. Unplasticized PVC is used for making sheets, light fittings, helmets, tires, refrigerator sheets, and mudguards. Plasticized PVC used for making continuous sheets of different thickness, tablecloths, curtains, toys, radio components, and thermal insulators. Okay, these are the two types of the PVCs and the uses of the PVC, polyvinyl chloride. Okay, next, preparation of polytetrafluoroethylene, or simply we call it as the Teflon. Okay, tetrafluoroethylene, when it reacts with in the presence of the acetyl peroxide, it will form the Teflon. Okay, here see the double bond is there. 4 molecules of the fluorine, tetrafluoroethylene. Okay, when N molecules of tetrafluoroethylene reacts with the acetyl peroxide, it will undergo the polymerization reaction and it will form the Teflon. Okay, we can see here the 3D structure of the Teflon. Okay, these are the carbon bonds, carbon atoms, and these are the fluorine atoms. Okay, when these react, they will form like the polymer. Okay, polytetrafluoroethylene, PTFE. In shortcut we can say as PTFE. The green color represented as carbon atom and the violet color with the fluorine atom. The present, coming to the some of the characteristics of and properties of the Teflon. The presence of stable CF bonds leads to PTFE with outstanding heat resistance, chemical resistance, electrical insulation characteristics, low efficient of friction. See here the Teflon we can use for in household cookings for non-stick coatings. Okay, non-stick cookware, the coating is mainly made up of the Teflon. Due to the presence of the highly electronegative fluorine atom, the CF bonds are very strong bonds. The fluorine is highly electronegative atom and it can withstand high temperatures. Okay, that's why it is used in the non-stick cookwares for coating, Teflon coating. It can withstand high resistance, heat resistance, chemical resistance, electrical insulation characteristics, and low coefficient of the friction. Due to these 4 properties, that Teflon is used as the non-stick coatings in cookwares. And coming to the characteristics of the Teflon, it is non-stick, low coefficient of friction as a non-wetting, heat resistance, unique electric properties, cryogenic stability, chemical resistance. It can withstand very low temperatures and it can withstand high heat resistance, and unique electrical properties are there. It is chemical resistant, it won't react with most of the chemicals, and low coefficient of friction means the surface is very smooth, and it is non-stick. That's why these are all the properties is used is helpful for the Teflon used as a non-stick coating for our cookwares. Okay, I hope you have liked this session. I have taken reference from the Engineering Chemistry by Ramadevi, Department of Chemistry, J into H. Thank you.